The questions in this section are going to, instead of having us find first derivatives, second derivatives, find local extrema, find inflection points, the questions are going to provide us with information about sign charts for the first derivative, second derivative, function values. So taking all that information that we've talked about and now look at combining it to sketch the graph of a function. So it's much more on the interpretive end of those results rather than on the calculation end of the results. So what we want to look at, for instance, in example 1, is a function that's continuous for all real numbers. We have a sign chart for the first derivative, and we have some different specific function values. So what we want to do is use that information to sketch a graph of the function, and then select that corresponding function. So there are different strategies for this, but one simple method to get started is to graph the different function values. So at -6, we have a function value of -1. So our first point would be at -6, -1. Our second function value would be at x equals -3, 1.1, so just a little bit above 1. At 0, we have a function value of 2. At 3, we have a function value of 4. And at 6, we have a function value of -4. So we can start by plotting those points. Now we want to use the information that we're given about the derivative function to determine the behavior of our graph between those 2 points. So we know that from -infinity to -3, our function is increasing. From -3 to 3, our function is still increasing. And from 3 to infinity, our function is decreasing. We also know that at -3 and 3, our tangent line should be horizontal just at that instant. So at -3, the tangent line is horizontal, meaning our graph is going to level out for a second there. And the same thing is going to happen at x equals 3. So what we want to draw is a graph that's increasing from -infinity all the way up to 3, with points where we level out at -3 and at 3, and then beyond that is decreasing. So we want a function that's increasing, levels out at -3 for just an instant, continues increasing, levels out again, and then changes to decreasing to pass through this last point. So all we really need to do is come up with that rough sketch of the function just to get the general behavior. And what we can see is that our correct graph in this case would be B. Clearly D is out because it's opening in the wrong direction. That whole graph is opening up versus this one is opening down. So that also throws out A. So we're just left with B and C, and we can see that the positioning of that graph in C hits the y-axis below the x-axis, so putting it in the wrong spot. So we want to combine that information to sketch a graph and then match it with the appropriate answer. We want to do essentially the same thing in example 2. The information is just being presented in a slightly different format. Rather than being given a sign chart, we're given information about intervals where our derivative is greater than 0, less than 0, and values where the derivative is equal to 0. So again, in this case, in this first box, or first cell, we're given some specific function values. So at -1, our function value should be 1. At 0, our function value is 0. And at +1, our function value is -1. We know that at -1, the derivative is equal to 0. So our graph should level out for a second. That tangent line should be horizontal. The same thing happens at 0 and at 1. We know that our function is increasing from -infinity to -1 and from 1 to infinity. So generally this function is increasing from -infinity to -1 and then again from 1 to infinity. and between -1 and 0, and then from 0 to 1, it should be decreasing. So just getting that general shape, and then we want to connect these in a way that makes sense. So we want a function that's increasing, levels out at -1, and changes direction to decreasing, levels out again at 0, but doesn't change direction, then levels out at 1 and changes to increasing. So we can throw out A and C, since they don't have the right kind of behavior. C has everything curving up on both sides, A has everything curving down. So we're down to B and C. In this case, B is the one that has that same behavior where our function increases, decreases, and changes to increasing again, leaving us with B as the correct graph given these different parameters.